Hello, we are Team Uber Scooter. My name is Maldonado.
My name is Niraj Chaudhary. I'm Ritesh Basavaraju.
We are mechanical engineering students at California State University, Los Angeles. We are currently enrolled in Dr. Landsberger's ME 4590 service learning course, Rehabilitation Design. Today we'll be presenting our final project. Here we have Johnny with our final product. Notice as he approaches a medium-sized ramp on the Cal State Los Angeles campus, he then proceeds to turn right. He does this confidently without moving a single muscle except for his wrist, which accelerates the scooter, which is driving him in his wheelchair. This was great progress. However, we did not get there overnight. Let's review how we first got here to begin with. Here we have Johnny without the 4-bar mechanism locked into place. Notice how it took him a while to get off and begin moving forward because the wheel was actually spinning in place. This was where we began, and this is where we first began our work. And this was one of the main problems we aimed to solve initially. Here we see Johnny trying the exact same thing, only this time on concrete. Notice how he also skidded, but here we get to see how much rubber was burned in this part right here. We drew a free body diagram of the scooter's wheel and found that friction force must equal force due to angular acceleration. We then built a cardboard model to better understand the situation. Realizing we needed more weight exerted on the front wheel, we decided to use a 4-bar mechanism to accomplish just that. This led to the following designs and prototypes. We used wood because it was easy to work with and tweak when modifications needed to be done. However, it was too weak, which is why we have additional wood below. It gave us the motion we needed to raise the wheels, so we continued. We made the following prototype much stronger by using steel clamps and steel square. After careful measurements, we proceeded to welding. Our aim was to lift up the front wheelchair wheels in order to have more weight on the front scooter wheel, in order to have more weight and most importantly have a greater friction force to prevent the slipping from occurring. The original plan was to have a lever for the 4-bar mechanism near Johnny so that he could lift himself up. However, we did not have time to make the lever longer, which is why we see Johnny with the lever already up when he begins to take off, now with the linkage locked into place. This is definitely an area that can be improved, not only for the accessibility of Johnny, but also to generate mechanical advantage, which will give it more leverage so that Johnny would have to exert less force when he wants to be lifted, since his weight is exerted on that 4-bar as well. Also, since we were limited to materials, since the 4-bar is made out of aluminum, it is not recommended to use this scooter on a daily basis since we expect it to fail after fatiguing on a daily basis. For this point in time in our design, we feel we have contributed to the group, but there is still much that needs to be done for future generations or teams who want to work on this project. Here we see Johnny testing out the scooter where he goes on a hill or ramp that is approximately 10 degrees at an angle. This shows how progress has been made and how it is reliable to a certain extent, but definitely not in the long run. Lastly, we would like to recommend bringing the handles a little bit closer so that the scooter could also be closer, which will allow Johnny to make sharper turns. As we could see here, he does have to turn a lot, and it's a long radius of curvature that he must go through in order to make a simple U-turn. Lastly, we would strongly recommend doing something to strengthen or relieve stress on the 4-bar linkage. The reason why we say this, because this is where we believe failure will occur, if it does, in the near future. However, this could be prevented by distributing the forces through I meant by triangulating the force on a more stable body, such as the frame of the scooter. Or stronger 4-bar mechanism could be applied. However, if we were to do this, this would still not allow smooth motion because the force of Johnny's weight would still be exerted on the 4-bar. We believe we have made good progress at this point in time. However, we also understand that 4-bar linkages may not be the answer when dealing with so much weight and pressure in the long run. When asked Johnny, our client, about any potential adjustments that could be done to better suit him, he said strengthening the 4-bar somehow, or also providing some type of brakes. Here we have Johnny without the 4-bar mechanism locked into place. Notice how it took him a while to get off and begin moving forward because the wheel was actually spinning in place. This was where we began, and this is where we first began our work. And this was one of the main problems we aimed to solve initially. Here we see Johnny trying the exact same thing, only this time on concrete. Notice how